Thank you for that introduction, John. Hello, everyone. My name is Sue Kaur, and I'm the lead systems engineer for the Data and Reasoning Fabric. Kicking off the first day of NASA's third annual imaginAviation, today we're going to talk with leading scientists and researchers about how they're using data to discover, catalyze, advance innovation in the aviation community. We're joined by Shivanjali Sharma of Air Traffic Management Exploration, also Dr. Kelly Hashimi, who is the tech lead for autonomous systems in Transformational Tools and Technologies, TCubed, and Dr. Misty Davis, the project manager for system-wide safety, SWS. Hello, everyone. Now, in my opinion, data in itself is nothing more than unorganized facts and figures. And some examples of data that people may be familiar with are the temperature and humidity outside, number of cars on the road, a map of all the roads in a given town. On its own, without context, the data has no purpose. It's not until we process, organize, and analyze, giving context to the data, that it's transformed into something useful, something meaningful. For instance, the temperature and humidity will tell you if it's time to turn on the air conditioning or if it's safe to fly your aircraft. The number of cars on the road will tell you how heavy the traffic is. And when you combine that with a trajectory, when you combine that with a map, you have a trajectory. When you refine and give context to data, it becomes information. And information provides insights, allowing you to see patterns and make predictions. Now, historically, data has been transformed into information by humans, but as the rate and quantity of data available increases, we need more processing power to turn that data into information. We need to automate and accelerate our data to information capabilities. This is where artificial intelligence comes in. AI is assisting humans to transform vast amounts of data from many diverse sources into information so they can make decisions quickly and efficiently. This is what we call reasoning. And when you weave that data and reasoning together, the result is a dynamic digital ecosystem we call the fabric. The fabric not only connects data and reasoning, but it also connects people who need data and reasoning and tools to the airspace operations that they're interested in. Today, I'm joined by researchers and scientists across NASA to learn about what types of data and reasoning they're working with, as well as the short-term and long-term benefits of the work they're doing. Now, I think we can all agree the future of aviation is going to be digital and data-driven, so we can develop sustainable solutions for the future. So to start us off, Kelly, can you tell us what kind of data and data sources you're looking at or working with in TCubed?
Sure. Maybe a little context first. So in TCubed, we are that far-term, long-time horizon focus for technologies. And we're focused on what we would call the UML 5 or 6 vision. So that means we have a lot of airspace operations. They're highly autonomous. And really, it's going to take a level of operations scalability that we can't do right now. So if you think, what is the fundamental unit in airspace? It's a pilot and a vehicle. And we think to reach these farther term visions, we're going to have to kind of push on that fundamental unit. Could we make it a multi-vehicle relationship, something we call M to N, where we have maybe one person or a small number of people that are overseeing, maybe not directly piloting, a much larger number of autonomous vehicles. In addition to that, the infrastructure is going to have to change to support that kind of operation. We expect to have a lot of different information sources available to us. Maybe they're dynamic information sources, so they might change from day to day or from operation to operation. And so we kind of have two types of data problems in our portfolio, I would say. We have maybe the onboard or the real-time type problems where we need to take all these information sources that are available to us and be selective about which ones we choose to use so that we can efficiently make use of the information, make decisions quickly. We also have the type of problems where we just need more data. Maybe we need to have data from a lot of different experimental conditions. Maybe we want to feed a learning algorithm. So I think we kind of span the range of data problems getting towards information to enable that long-term vision.
Thank you, Kelly. And Misty, would you mind speaking about how data is being used to support safety?
Absolutely. So right now, my project is working on what is the National Academy is called an in-time aviation safety management system. And the idea is that today we have remarkably safe transportation for the kinds of airplanes you go to the airport, get on 200 people on a plane. It's honestly one of the safest forms of transport today. Part of the reason for that, especially in the United States, is that we require folks to have this thing called a safety management system where they're constantly looking for safety issues. And we have systems in place basically to reward people for pointing out things that may or may not be safe. But today, the vast majority of our signals, the first clue we have about whether or not something is safe, is a person reports something. That's usually a verbal report. And honestly, a lot of the data, the evidence that you would find for whether or not there's actually a safety issue, um, it's kind of hard to get to in a few cases. There it may be that you actually have to walk out to a vehicle with a USB key to collect some data in order to actually understand whether or not that was a problem. And certainly, if you want to know if it's a nationwide problem, you may have to do that for several different airports, for example. So it can take, honestly, months from the first time somebody reports, hey, I think there's a safety issue, to the time you've actually determined that it is, in fact, a safety issue, figured out the scope of it and how to fix it, and put a plan in place. What we've been looking at is trying to figure out how to shorten that time horizon so that again, we're in time to prevent incidents and hazards. We're moving towards a more predictive model of what safety is. And what that means is that we have to be able to more quickly gather that data. And just as you pointed out, make sense of it. Right now, we're depending on the people in the system to say, oh, I think this is an unsafe thing because, and now we're trying to figure out how to automatically have the systems in our lives point that out to the people quickly.
Thank you, Misty. And Shivanjali, can we have you talk a little bit about the reasoning agents on the ATMX side?
Sure, thanks, Sue. I'm currently serving under the Air Traffic Management Exploration Project, and that project really at the core and the heart of it is data and information and how we leverage that data and information to transform our current air traffic management system. Like Misty mentioned, we currently have the safest aviation system in the world, and part of that is really due to the manner in which our air traffic controllers and pilots leverage the data that they have access to. But as we are trying to shift to increasingly sustainable operations, and we have potentially new entrants coming into our airspace, our project is focused on understanding what types of models, simulations, and algorithms can be developed to enable increasingly scale of diverse entrants into our airspace, and also ensure that our operations become more efficient. And really at the core of that is how we leverage data. So I'll talk about it in a few different ways. One way in which data is essential to the air traffic management system is you have air traffic controllers. And air traffic controllers, and in particular, you can imagine a traffic manager. They are inundated with data. So if you think about your office, you might have one or two displays. In a traffic management unit, you have potentially 5 to 10 displays, all containing different types of data, whether that's numerical information, text, maps of weather cells that may be coming into a particular region. And it's really up to that traffic manager, that individual utilizing their gray matter to synthesize that information and make sense of it. And that's really, I think, at the core of what all of us are working on, is how do you take data, synthesize it, and then leverage that information to provide tools for the humans that are in the system. And then as systems become increasingly automated, leverage that data to make decision-making processes. And that's part of what we are exploring, or what are the tools, capabilities, features that can be provided to make our air traffic system safer, much more efficient, and then allow new entrants like small UAS or drones or electric vertical takeoff and landing vehicles come into the system and start operating, such that we can all move ourselves and goods more effectively and efficiently.
Thank you, Shivanjali. We're all working on such incredible projects, but using data with a common purpose. And now that we know a little bit more about the types of data that is available, as well as the people who are using this data, I'm wondering, what are some methods we can employ to make that data and information more actionable? Kelly, what are your thoughts?
I'll give you some high-level thoughts here, actually. Number one, I think getting data out to combine it with more data makes more data and makes that data more valuable. So it's a nonlinear value proposition here. So especially as we start moving into operations, new types, Shivanjali mentioned small UAS operations or urban air mobility, having data that applies to those kinds of operations and the settings that those operations occur in is going to be a challenge that we need to come together on as an aviation community, to build data sets that will be sufficient to help us pursue increasingly autonomous operations. I also think that it's important to understand the space of data that you need. I don't need a bunch of data where I'm flying in the same corridor during a sunny day with no other agents or birds entering the scene. I actually need a matrix of data conditions. I need to know, what happens when I'm flying at dusk and dawn, when that bird flew by, when something went wrong, when some contingency came by. So I have to be intelligent about the data sets that I'm trying to construct, and cognizant of what I have and what I don't have, because in turn that translates to limitations of the tools and technologies that are being developed.
Thank you. And Misty, what are your thoughts? What can we do to make data and information more actionable?
So I love everything that Kelly just said, because again, fusing that data is really important for us to make sense of it. Now, that being said, today the sort of autonomous agent in the system is a person. It's an operator who's really having to make sense out of all the data. And people are fantastic pattern finders. We're pattern matchers by nature. What we don't do well is monitor. So we're not really great at just constantly paying attention to something that's boring. That's one thing we're horrible at. Another thing that we don't like is a lot of false alerts. So if something is constantly going, look at me, look at me, look at me, and when we look at it, we don't have to do anything about it, we will eventually tune it out.
Mm-hmm.
So this has been a big challenge for us as we think about trying to help the people in the system make good decisions. We have to make sure that we don't give them a lot of really bad information, because they're just going to tune out whatever it is that we give them. And the other thing is, we also need to make sure that we don't drop patterns that people would have found automatically, right? We need to make sure that those always bubble up. So that's been a big focus of our project, is what do we need in order to help people who will still be in the system make good choices, and make sure that they understand their roles and responsibilities, and make sure that we're giving the people the right roles and responsibilities as we add in all this increasing automation.
Thank you, Misty. And Shivanjali, you spoke about reasoning agents on the ATMX side. So I'm wondering, On your side, what are some methods you're employing to make data and information actionable?
Yeah, thanks, Sue. There's a number of ways in which we're leveraging data, and I would say, one thing that's important is not all data is equal, right? And so understanding the quality of data and what data is reliable is quite important. And so I'd say in order for us to understand how to make data actionable, it's very important first to help us understand, well, what is the data that's available? What is the data that's not available that we need to either collect or ensure that we have potential methods of collection, and then understand, well, if you have all these different types of data, which one is the best source to select from for the given problem that I'm trying to solve? So, the analogy I like to use is if you're, choosing a camera, you have different resolutions of a camera that you might apply for different pictures you'd like to take. It's very similar when we're leveraging different types of data. We have to pick the best source of data to ensure we're able to execute the mission that we're trying to execute. So if we're looking at it in terms of air traffic management and, for example, providing capabilities for controllers or even developing services such that we can manage the flow of air traffic, it's very important that we understand what are the different types of data that might be available for us to understand the number of aircraft that might be taxiing on the ground, their trajectory on the ground as well as in the air, and leveraging that information to understand that when you have now hundreds or thousands of aircraft in the sky, how do you manage the flow of those vehicles and provide tools to air traffic controllers and air traffic managers such they can conduct the symphony of our national airspace system. So they're very much an orchestrator, and how do we give them the tools to help orchestrate efficiently and effectively such that we can better meet our sustainability goals, as well as allow some of the new vehicles that Kelly and Misty also mentioned into our airspace. The one thing that I think we talk about contingency management, or when things are maybe not the most optimal, whether it's due to weather or disruptions in the system. And when that occurs, it's very important that we have the right types of data. And the way that I like to think about it is, we have 3 steps that we need to think of when we're going through contingency management operations. And the first is orientation. Where am I in the world? What is going on around me? So that is a very data-rich type of problem. The second is then predicting. Do I have models that can accurately help me predict what the future state would be of, for example, our air traffic flows? And that is also a very data-rich problem because we have to train our models such that they come up with accurate predictions and then execute based on those predictions in our current state, our mission. And those are all types of activities of how we leverage data and try to make actionable use of the data in a very broad sense, but it applies to whether you're an air traffic controller or a pilot in a flight deck. And that's how we try to make data actionable.
Thank you, Shivanjali. Wow, I've learned a lot from all 3 of you about the projects you're working on, and we've had a really good discussion on what is data, what is information, turning data into information, and the future of it all. But now I'm wondering if maybe we can shift gears and talk a little bit about how the work we do is benefiting the public at large. So Kelly, I'm going to have you start off the conversation again.
So again, we're kind of that far-term focus. How can we start to create tools, technologies that allow us to change the relationship between how humans interact with increasingly autonomous aircraft in the airspace? And so it's kind of use case agnostic in a lot of ways. You could apply this to a lot of different existing operations or new types of operations. But I think it offers some general benefits, regardless of what use case you're looking at. The first one, workforce. I don't know that we have the workforce available to us to be able to maintain that one-to-one paradigm as we scale up to the number and density of operations that we envision in the future. I think it also allows us to, if we don't have that one-to-one relationship, if we have the small team to many relationship, you have the opportunity to bring in other people to that small team. And maybe there's a specialist that you can call, and you couldn't call a specialist to come help you, join you in the cockpit to help you fix the problem. So I think it opens up new roles and responsibilities for the human to the aircraft. And hopefully that would lead to a safer operational status. And maybe importantly to some of our industry partners that might be joining us here today, I think that level of operation scalability enables some of the business cases that we see. Drone delivery, for example, if you had to have one pilot for every package that was being delivered, that's cost prohibitive. And changing our human operator relationship is going to allow us to scale profits, monetary value, as we move towards those future visions of density.
Kelly, I remember we talked about how this may also impact culture and policy. I was wondering if you could discuss that a little bit.
Yeah. Again, I think the multi-vehicle operator paradigm, it's not a near-term change. It's not coming in the next 2 years or anything. It's going to require not just change to how we build aircraft, the level of autonomy on board that's required, but you think about how you, as a member of the flying public, would have to be comfortable with getting on an aircraft that doesn't have a pilot right there, maybe even is thinking about more than one other aircraft. So I think that there's a culture shift that comes along with that. There's obviously a lot of regulatory safety progress that would have to be made before we get to that point. So it's not just let's build a new control system, let's build a highly autonomous aircraft and be done. There are a lot of other non-technical pieces of the puzzle that have to come into place as well.
Agreed. I totally agree with that. And Shivanjali, I'm wondering with ATMX, can you just tell us a little bit about the broad public benefits, either short-term and or long-term?
Yeah, sure. So I think we have the opportunity to work on several aspects of transforming our air traffic management system for both some near-term, I think, public benefits as well as further term. So the first near-term public benefit is we're working on developing algorithms and using machine learning techniques to help create optimal and more efficient trajectories to save fuel. And if we are able to provide operators like the airlines and air traffic control with these potential optimal trajectories, leveraging data, again, that's at the heart of these tools, then we're able to start to reach some of the sustainability goals that we've set, as well as ensure that the aviation system as a whole starts to understand how there's a potential for taking existing traffic, whether you fly a 737 or a different type of aircraft in today's system, there's opportunities to ensure that the amount of fuel that's utilized is reduced, whether you're sitting on the runway or on a taxiway or in the air, by optimizing your trajectory both on the ground and in the air. So that's one way in which we're developing capabilities to really support the overall public. The other way is I think there are really some unique capabilities coming out of these emerging entrants. I'll focus on the small UAS or drone use case, as well as some of our autonomous cargo types of applications that we're working with some of our partners. So as we start to think about these types of applications, if you are able to have a small UAS or drone deliver, for example, medical supplies or collect samples from a location that's remote, you're able to actually have the potential to support a number of different individuals and communities, whether you're in an urban or rural environment. And for example, there are oftentimes communities where you'd have to travel an hour to 2 hours to reach a medical facility. So can we leverage some of these emerging entrants to really help us in our daily lives? And that's part of what we're exploring through developing algorithms, trajectory management systems, services, protocols to exchange data to enable these new entrants to operate safely in our national airspace system. And it's all for these use cases that are really to help us at the end of the day go about our lives in a little bit more of an effective manner, especially for those that who may need it more than others.
Yeah, thank you for that, Shivanjali. On the DRF side as well, we're looking at medical use cases, right? Like What if we could deliver medical equipment like defibrillators or medication, whatever you need, to areas that are underserved by the aviation community right now, living in rural areas or outskirts of the metropolitan areas. Um, and I think that's one of the things that keeps us all going is the ability to serve people and find solutions and connect them. But another area that we're also looking at is, climate change induced wildfires and just in general emergency response, being able to make those decisions quickly and efficiently. So, Misty, can you tell us how system-wide safety is contributing to the benefits when it comes to responding to emergency situations?
Absolutely. So system-wide safety has use cases that run the gamut. And so certainly with our near-term commercial partners, while we really are enjoying working with them to figure out ways to get them actionable information more quickly, frankly, we know that for the near term for commercial aviation, that's still going to be a very human-centered operation for a long, long time. For some of these more advanced capabilities and for looking at scale and for some of these new opportunities that you're talking about, we're going to have to rely on advanced automation and autonomous algorithms, autonomous ideas. And to our mind, the biggest public benefit, and NASA is largely about public benefit, we're a taxpayer organization, is in the area of emergency response. So for a lot of our ideas about really automating safety assurance and about making sure that the autonomy that we introduce is still safe and behaves the way you want it to, we're relying on emergency response use cases because, first of all, we think that's where the biggest benefit to the public is going to be. And also because, frankly, that's where we're going to accept the risk of some of these new operations. So we have fantastic partnerships right now with people who manage large scale wildfires. One project that's not here, but that I think you'll hear about a little bit later, Acero, really is focusing on wildfire and so we all talk to each other. We're partnered with them as well in order to really understand that space and make an impact there, enable those. But our cases go all the way through not only wildfire response, but also hurricane response. We're seeing with climate change that the East Coast is having more and larger storms. Certainly the storms across the United States in the last week have demonstrated that there's a need there. And then out to routine medical use cases, even in urban environments. And then finally out to large scale disasters like earthquakes or other large scale urban disasters where you have a whole bunch of folks with different missions who descend simultaneously to respond. That's honestly a fantastic place for NASA to advance um, and push these technologies for safety, for efficiency, just to understand scalability.
Thank you, Misty. And with that, I think we're ready to take some questions. We have about 5 minutes. Let's see. So I guess one of the questions is, what are you looking forward to the most in the span of the next year or so? What can we expect to see? Some highlights, some examples, demonstrations from any of your projects?
So we actually have some work that just is wrapping up with our airline partners right now, just for today's work, and we'll be highlighting some of that this summer. So my assumption is certainly pay attention to the NARI page. And you'll be able to see the advertisements for that. But we're really excited about some of the safety work we've managed to complete just with our airline partners in the near term.
And if I can add, Sue, one of the things, Misty mentioned our airline partners. One of our projects that's focused on sustainable operations is actually functioning in the field right now. So through our collaboration and partnership with the FAA and airlines, we're actually demonstrating some of the algorithms leveraging the data that we've been all talking about through this session, and providing those capabilities to air traffic controllers to make more efficient operations and make more efficient operational decisions. So hopefully folks will be hearing more about more of that as we are able to produce some of the results and share some of our data back out with the public.
Kind of related to Shivanjali, in T-Cubed, we have some tools that we are moving towards an open source release. I can think specifically in the next year, I hope to see the Human Autonomy Teaming Task Battery coming out. We have some contingency management simulations and algorithms and tools also coming out. So again, trying to further a new operational architecture across the use cases by making these kinds of tools available.
And on the DRF side, we are currently doing field testing in a simulated urban environment with our partners in Phoenix to talk about, to study the medical use case I mentioned earlier. But we're also going to be working with California Civil Air Patrol to see how we can reduce the response time when a lightning strikes, there's a blaze, and see how we can actually help that team. And I think we have about 1 more minute. So if anyone wants to share something or, give some advice, now would be the time. I'm wondering, how did you all get into the field you got into? I don't know if we can cover that in 1 minute, but if you have any advice, I'm sure our viewers would love that.
I'll take the bait, Sue. Someone told me it was hard to be an aerospace engineer, and I think I took that challenge as little 8th grade Kelly, and here I am. So don't be afraid to do something that scares you or looks big and challenging.
To be honest, I think I got into this for the same reason that someone said, "Oh, it's impossible." I'm like, well, is it? Let's find out.
Thank you so much, Sue.
Thank you, Sue. Really appreciate it.
Thank you, everybody.